Recently, I'm hearing a lot around the internet that, well, CGI is not as it was used to be. And I'm like, kinda, yeah, there's a couple of factors. So the whole thing that Hollywood CGI have gone down in terms of quality goes to three parts actually. So one part is storytelling, which everyone knows why it has been built. The second part is, well, the industry itself, that there is a whole drama about animators and artists in the industry is happening. I'm not the best one to go and hear their words about this. There's a better video about that, and it's in the description. Please go watch that video if you want to notice the reason about the artist. And there is a reason that is software. Visual qualities are all goes back to renderman, because that's the program responsible for translating whatever in the 3D program to what you see on the screen. So how renderman got advanced yet suddenly got dropped? It actually got more advanced. It's that companies are preferring to use the less advanced part of it. Renderman at origin was called renderman. They had only one algorithm in it, and it was Pixar Path Tracer. Yes, Pixar really likes with these acronyms, PXR. Haha, funny Pixar. But you will see a lot of these acronyms in here. So the first one was actually renderman itself, which Pixar Path Tracer. Then came Pixar Reyes. Yeah, it's another acronym, rendering everything you've ever seen. Reyes. So, Reyes actually got introduced in Toy Story. It was around the Toy Story that brought out the renderman non-commercial. But Reyes had some sort of limitations. First, the quality was way ahead of its time, right? As you can see, Toy Story was huge drop in quality, right? Then they start advancing a material they would like to call it at that time PXR Disney material. It's at the time that they got bought out by Disney. The Pixar Disney material, the way they visioned it, it was supposed to include all types of materials in itself, right? Literally rendering of everything you've ever seen. No matter what material you have seen outside or you imagine it, PXR Disney should be capable of producing that for renderman in order to render the same exact material. But Reyes has some sort of lightning limitation, it has some sort of CPU limitation, it has so many limitations, right? So they deprecated that. They introduced a new algorithm that was based on Reyes and the Path Tracer, Pixar Path Tracer that they're using originally, called RIS, or again, Renderman Interface Specification. RIS and Reyes, in the terms of, I don't know, I'm not a programmer and it's not an all person's programs, I don't know in terms of code how much different they are, but I know one of the major differences is that Reyes was rendering the whole picture in the same place, but RIS was using cores and putting every sample, which is every single light ray simulation, beside each other and add them on top of each other until you get a full picture. One of the places that RIS got very advanced at it was during Monsters University. That's why Monsters University suddenly had a jump in quality, because that was the point of completion of RIS. And RIS had way faster than Reyes, but it wasn't that much fast. One of the major problems still today that there is with 3D rendering, even with RTX graphic cards, is that they are super slow. Monsters University, every single one of them took between 24 and 26 hours. Pixar's solution for this, instead of just using one computer to render that one single frame by thousands of computers, right? Design a program that manages the renderman's task between each computer, which that they call that program Tractor. And Tractor distributes the task between each computer. And that's the idea of render farm begins, right? So each computer is rendering a single frame independently. So while 24 to 26 hours was every frame rendering time, but it was like thousands of frames all at the same time. But even with that, it took 2 years. It took 2 years to render that thing. It was like 1 year and a half just animating and 2 years just rendering. And that's not even down the pipeline, like that last step. Then there is compositing and then there is editing. They were like, okay, we need to make it fast. So the way that clicked that we need to make RIS faster than Reyes, it was already faster than Reyes, but we need to make it even faster, was during about renderman 20, version 20. They were optimizing, over-optimizing, until renderman 22. Actually, one of the very cool features that renderman have added in renderman 20.21 was checkpointing. It was such a cool idea that actually made one of the different points between Reyes and RIS, which was because Reyes was rendering the whole light rays and everything all at the same time, but Reyes was building light rays on top of each other. They could actually save in the picture that, okay, we rendered until this amount of light rays. And you can actually set it like every couple of minutes, every couple of hours, or after this amount of samples after the last checkpoint to make another checkpoint, and actually saves the picture with the data of how the light rays were. Then, if I don't know, light goes out, one of the servers dies, something happens, and they can recover and resume the rendering from the last checkpoint they made, which is such a cool idea. But that wasn't it. One of Disney majors hit, and it was Frozen. And I don't remember what was it. It was one of the major Disneys. One of them was Frozen. The other one I don't remember. Either way, Disney developed a tool called Denoiser. And yes, the Blender Denoiser idea comes actually from this Denoiser. This was the OG Denoiser. And that's what actually the start of AI going around. It wasn't picked up like now and then ChatGPT came, but there was some sound of like, yeah, we're going to develop AI. And Denoiser actually was one of the AI, right? It was AI that was trained on how is a render with low sample and noisy, and what is a render with high sample and smooth, right? This was the idea. You render a picture that is pretty much noisy. You don't need to go to the full sample, and then you feed it to AI and it gives out the smooth version. That was the whole idea of Disney Denoiser. The problem being is that, well, it's not as detail oriented as if you go with high sample rate, right? You're obviously going to blur out some details and you're going to miss some details. But the more high sample you feed it, the more less noisy you feed it, the more output is more detailed, right? That's how the denoiser works. This was another faster point, but let me do a simple calculation for you. At that time, I was doing another MLP animation. It was like 10-second animation, and it was fail animation, by the way. So, you know that the rendering never finished. I rendered it like 20 hours per frame, and I had one potato computer at that time. I could go with 10-hour rendering, 10 minutes of denoising, right? The denoiser wasn't that fast as the denoiser of they have currently. A simple math, right? 10 seconds, 30 FPS, 10 times 30 means 300. 300 times 10, at least 3,000 hours just rendering the frame, right? Only for 10 seconds. Then, adding that to that, every frame needs to be denoised, and we assume that the way I remember it was 10 minutes every frame. So 300 times 10, 300 minutes divided by 60 minutes 5 hours was just denoising, then the total render time at minimum would be 3005 hours. It's a lot. During renderman 22 or 23, because they made a live stream on it. They actually made a live stream on it on Q&A on how they want to manage and continue the iteration and improvement of renderman. And a couple of artists bunch of them are from different companies, asked one simple question that if you want to blame the bad graphical quality of today, you need to blame them. They asked, renderman is only using CPU. Does Pixar ever plans on making renderman compatible with GPUs? Boom! They were speechless. They decided to answer and actually read it on a stream, but then they were like, there was so many ums in the answer. I don't remember the exact wording of it, but it was something among the lines of, we have thought of it, we tried a couple of things, GPU is very different than CPU, we need to figure out what to do about it. It was something among those lines. renderman version 24 was made for Project Soul. This project needed 2 different things. Fast rendering, because for some reason Disney and Pixar were on a rush, and they needed a stylization. So they actually made 2 major features suddenly into renderman. One of them was a stylization. The second one, they introduced XPU, another Pixar's dumb acronyms. So if you want to know where XPU comes from, GPU, CPU, GPU plus CPU, XPU, cross PU, something like that. Basically cross processing unit, something like that they have in mind. Either way, the idea behind XPU was that instead of renderman just using GPU or renderman just using CPU, because at that time they made denoiser to be compatible with GPUs, although today's denoiser is not compatible with GPUs, ironic. They wanted renderman to be able to render with both CPU and GPU, so it can be even faster, because the more faster they render, the more animation they can make. Also, there's less electricity bill for handling the render farm. XPU at that time was only for commercial. A non-commercial user like me couldn't use it. So I have no idea how it was at that time, but I know it was pretty limited. Stylization was for commercial users as well. It wasn't for non-commercial users. 25, they brought both of them to non-commercial, but stylization was complete, and XPU, oh boy, was such a mess. XPU was such a mess. XPU has non-complete parts left and right. And this is the part. Today's companies, animation companies, are able to choose between RIS and XPU. But the difference in terms of speed is so much different that I cannot tell you about it. And the funny part is that XPU is only compatible with NVIDIA GPUs, right? And after 4 years, they haven't not made it compatible with RTX yet. It works with RTX as it works with GTX. It only uses the CUDA cores. It doesn't use RT cores at all, which is funny actually. So XPU is super fast, and the better GPU you have, of course, the faster it gets. Now, here we are. Companies have the capability of RIS still. They can go use RIS. And there are 2 versions after that XPU got introduced. We have renderman 26. Because XPU is extremely fast, they often choose XPU. And look at how many limitations XPU have still compared to IRS. It's ridiculous. So, yeah, the XPU limitation is the reason that the graphical quality have gone down. Because I'm reading a couple of it. Okay, so if I actually go to renderman documentation for 26 version of renderman, by the way, I know that 27 is in beta test, but either way, and then go to XPU guide, XPU features and limitations. Just to name a few. It doesn't support llama materials. Llama materials is only for, like, you know, team wise deciding on rendering and through different programs. Llama, it's only introduced like 2 versions only. It was introduced since 24, so it's not that much. It's not like the other companies and people don't have methods to deal if Llama is not working. C++ patterns. C++ patterns, they basically saying C++ renderman plugins. That's what basically means. OSL patterns is the same thing. It's OSL renderman shading plugin. The same thing. Actually, OSL stands for Open Shading Language. So it does support OSL patterns, which is the OSL is the slow one. C++, on the other hand, it doesn't support it, which you can imagine that rendering is very time consuming. So many companies have gone with C++, so they cannot use that on XPU. Texture baking is not supported. Point cloud. Point cloud is basically rendering a dot. XPU can render a whole geometry with lightning and everything, but it cannot render a dot still, which I have worked in programming with GPUs and how point cloud rendering works. It's really ridiculous that they have not implemented it yet. Custom BXDF or displacement plugins are unsupported. BXDF or BSDF, that Maya and Blender like to call it, but BXDF is a little bit more advanced than BSDF, is the algorithm of the shader and how it should reflect the light. So you cannot have the custom shaders yet, although Open Shading Language is supported. So whatever the hell this conflict is, normals are way different. Normals and bumps are way different. Yes, the C++ patterns are the same as C++ plugins. Here you can see it. No support for custom C++ plugins. Patterns written as OSL are supported. Peaks are XE expression. XE expression is the same as OSL and C++, but you need to compile them per a specific platform. But XE expression is a renderman internal lightning configuration that we can say, okay, I can do the shading of this geometry based on this expression, right? And the funny part is that the advanced ones is more supported than XE expression, which actually XE expression was used for Godzilla. The Godzilla back as point that was glowing was SE expression material. It's not support that. Dirt is basically their renderman's internal system for ambient occlusion. You don't need to fit a renderman ambient occlusion texture. Based on the lightning and the geometry, it can decide on ambient occlusion, and you can just attach a pixel dirt to your material to determine how much ambient occlusion you want on your geometry and control it. Pixel curvature, which is change of the material based on the curvature of the geometry, is not supported. Point cloud, which I said what it is, bake, texture bake. Point cloud is not supported. Texture is a non-square pixel, which is texture with Sony style pixel, are not supported. Volumes. Volumes are basically fogs. They are fogs. There are nothing more than that. We have so many names in here going around, but volume is basically fog. But we have different type of fogs, because some types of fogs get rendered like clouds that here it's called aggregated volumes. Some fogs are getting rendered like a smoke, which we call it blobby DSO, and some fogs are getting rendered a light beam. So we have so many type of fogs here, and so many types of them are not supported here. OSL, the Open Shading Language that they really said about that it is supported, it has limitation of supportation. XPU, NURBS, nobody cares about it in animation and CGI. Points, fall off is not supported. Blobbies and quadrics, basically a smoke simulation and fluid simulations are not supported. Procedurals, any type of software design that tells renderman, okay, this is how this geometry shape is, except polygons, is not supported. Nested dielectrics. Nested refractions. This is basically nested refractions. Like when you put a spoon in a water inside of a glass, and that spoon gets refracted 2 times because of the water and the glass and the air. So you now see the part of the spoon inside the water displaced from the spoon, the actual location of the spoon. Dicing cameras. Subdivision, the Cadmium Clark, which is the best one, is not supported. Point follow, we already said it. Nested instancing. Normals is a little bit normal, but not that much normal. String geometry. Primevars are not supported. Lightning mesh light, basically you cannot turn a custom object into a light source. Even the default lights have limitations. Does not support manifold next event estimation. Oh, okay, this I need to describe it, but I go later on and describe it. So this is the path tracing algorithm of Pixar. Path tracer, unified. Unified is the golden child of Pixar in terms of accuracy and performance in terms of path tracing. These 3 visualizer, differ, and tracer for development looks, so animators can get a basic idea on how their animation look like after rendering. You know that Zootopia, that deleted scenes that you see, it's like in 3D software, that's Pixar visualizer. Pixar default is basically Pixar path tracer, but a little bit way less features. A set of light rays that you say, okay, this goes. It's related to Pixar Unified. So somewhere in between XPU and path tracer, Pixar had this cool idea, because you cannot render a couple of things accurately with just path tracing, which is caustics is one of them, and correct reflections. The reflections that we see is a little bit fake reflections, not 100% correct realistic reflections. The whole idea that it's a deprecated algorithm and they don't see it here, but it is in the renderman. I use it very much because I hate Pixar unit. There was an algorithm called Pixar VCM. They never tell that what VCM is a stand for, but V stands for vertex and M stands for merging, so I don't have any idea what C stands for. Either way, the cool idea about VCM is that it path traces from camera to object to light source, but trace that back the same path from light source to object to camera. The difference in refraction, because there is a subtle difference between the refractions that happens, causes the extremely accurate caustics and reflections, and also refractions. But it takes time, because every ray needs to be simulated 2 times. That's the cost of it. So they came up with the idea of Pixar Unified, that they use the UV manifold unwrap of geometry to map the photons on a specific object and lights, so they can selectively trace it back instead of all light rays gets traced back. So you have this mixture that some parts that you want to look extremely realistic and accurate, you do it bidirectionally. Some parts that, well, it doesn't matter, you do it like Pixar path tracer. And XP doesn't support it. XP doesn't even support VCM. Post-processing, denoising. Of course, XP supports denoising. Sample and display filters. Basically, filters of the render that you want to use in compositing and editing. XP doesn't do that output yet. Deep output. Deep output is actually really cool. It's actually sets the depth of each pixel. Then you can mix the pixel depth with colors in editing or compositing, so you can edit in 3D in semi-accurate way that matches with the sim perfectly well. A holdout is whatever geometry that is invisible, but it's collecting a specific shadows or specific reflections. It doesn't support that. Holdouts are actually one of the major points in CGI. because you have a shot of an entire like real world scenario. You want to put, I don't know, Godzilla in it. Godzilla, of course, casts a shadow on the ground. So you make a 3D plane below Godzilla and make it a holdout so it only collects the shadow of the Godzilla. Then using the dip output, you mix them together to make it really look like that, well, the shadow is happened in real life. But it wasn't. So these two are really major for CGI. The checkpointing is not supported in XPU. Only output 2 formats. Some geometries are available under the same name for RIS. Multi-camera, multi-frame is not supported. The weighted option for pixel filter mode parameter to the hider will not be supported. If weighted pixel filter mode is basically how much each pixel was important to the rendering, which only is important for statistics and optimization of the render, which they actually replaced it with live statistics, so you can actually see on live while rendering to see what part of the scene is taking more time and it's important, so it doesn't really matter. Baking, we already covered that it's not supported. Cached presence or opacity is not supported of transparent surface, may be sharper as a result. So you cannot even make something transparent in XPU. Then we have to projection plugins. This is basically the control of camera lens that Pixar gives you. We have perspective, which is default perspective lens. We have Pixar orthographic, which is an orthographic lens. We have Pixar camera, which is an advanced camera lens settings being simulated. Some of them are not yet supported. Pixar Light Probe is very advanced. I'm not going to say it, but it's basically treating some light sources as camera in some sort of way. Pixar Panini, I will skip it, go back to it. Omnidirectional stereo, 360. Stay omnidirectional. It's basically 360 and it's a stereo. It's useful either for VR or 3D. It makes sense why they not supported it yet. Pixar Panini is fish eye or like insect's eye. Now you see how many limitations XPU does have. This is why CGI quality have gone down in terms of graphics, because they're rendering with XPU right now rather than RIS. Good part is that I heard that the next version of renderman, which is 27, and it's in the way and it's in beta testing, has way better XPU improvement. So well, XPU is not yet completely complete in that version yet either. So yep, I rest my case. Bye-bye!